Hi everyone, I'm Dylan Kawalec, and I'm going to be doing a presentation on what we've been doing in research and development at Osmosis. I'm really excited to show you this because it was sort of a aha moment for some of us at the team, and I'm here to kind of explain to you all things in relation to using enclaves to verify code delivery, how to decentralize the front end, and also offer, I think, some areas of interest that maybe some of we can collaborate on to bring more clarity to the topic. Okay, so first of all, just thank you to everybody that was involved in the process. Osmosis and Dave Oha was like a huge help, and really appreciate everyone at the team also just giving their feedback on how they would interpret decentralized front ends. Also, Flashbots had been closely working with us so that we can sort of solve the DNS IP mapping if we were going to be doing a decentralized, sort of like a way of doing a bunch of trusted enclaves that could have been either app chains or not app chains because they're not necessarily, Cosmos. So we had a lot of discussions on how can two disparate networks still have an agreeable messaging format or some sort of trusted, secure channel between two disparate networks that might not natively communicate with one another. So they offered a lot of assistance in that. Fortanix came through as the Rust SGX, so everything that I'm talking about is going to be in relation to just using Rust and the Fortanix SGX SDK. And so that way, when I don't show you code, you'll probably hopefully know what I'm talking about. And then Succinct, because Succinct is running SP1 proofs, and so we had done some mind mapping on exactly how we can create binaries that could do verifiable code delivery, but also submit proofs that clients can verify. And I thought actually the whole light client, decentralized light client opportunity is pretty fit for this. So the options of DFE right now, and I think everyone in this room maybe at one point has thought, like if you do over maximalism on decentralization of anything, if you think about like how do we do a completely decentralized application, most of the time you'll just kind of come to two options. You'll either go to say, hey, let's just put everything on IPFS. And I would say doing the IPFS narrative will do a few things. First, it'll bring the narrative of decentralization to the application, and especially for like a user's perspective, I think that was like the #1 thing that people really mainly understood. If it was IPFS, it was decentralized. But then when we deep dive into the problem, it doesn't solve the decentralization front end completely, and I'll show you that. Basically, it's not super performant. And there's some examples that I'll show you as well with Uniswap using, of course, an IPFS, and then basically pinning CIDs, and then routing this, basically the front end, to some, name server. And at the end of the day, is it really decentralized if it's still the same name server that's having all the liability of serving the code itself? Questionable to download it as well. I don't think anyone wants to have their users download cryptocurrency any application, especially if they're going to have to start putting private keys in the application, not necessarily knowing what's going to happen once I enter any data. So I think I've just found these to be questionable, and there are DFE solutions where if they wanted to do some sort of incentive model, they would be serving, hey, download this application, and that way I can actually do the sort of tracking of some sort of decentralized interface. Because otherwise, if you're not going to be doing any of this, you're stuck with weird links through IPFS, and I think there's just better ways of doing this. So who wants it? Yeah, so Uniswap currently does it with an IPFS CID header that basically any IPFS server will just pin to their server. Osmosis, clearly, I think there are lots of reasons why the front end of Osmosis is it's like a lot of it is client-side facing, so a lot of the rendering can be done by the client, and we can do a very easy, verifiable code delivery. And then somebody like Curve had also expressed interest in doing something very similar. Also, I talked to BitTensor, and they had a lot of interest with doing some kind of decentralized agency. So if the browser was going to do some sort of like AI render, then they would want to be able to do some sort of computation on the client side, and then maybe just distribute these agents directly to the client. So they thought, that would be interesting with doing something with their subnets. and that way it would be pretty equitable for their subnets to then levy, I guess, some sort of incentive mechanism to serve AI agents, which I think is cool because we can likely do confidential AI in this way if it's decentralized. Anyway, obviously Unstoppable Domains and ENS, they had done a lot of work with .box domains, and so if you don't already know, you can NFT a domain. So you have the TLD that's physically, literally posted as an NFT on Optimism. And so we can basically say, hey, I have this domain, it's in the form of an NFT. Now that I have this asset, I think it's cool that we can likely transfer the ownership of this asset. And what we're gonna explain is why are other companies like Near is doing this with .near, I think Secret Network just recently did this with .secret. Harmony was doing this with .country and .one, so the trend is going to continue, and they have these IPs, and so they're looking for an option of completely making it performant decentralized front ends. So they're interested, and obviously IPFS and Arweave are saying like, hey, use our databases for some part of this stack, and that's totally fine. I think we can see them being mainly used for basically proxying the code, not necessarily for it being the main host of the code, and I'll show you that in a second. Anyway, secret, and I asked everybody this question: what happens when we DFE? And there's like 3 points to this. Censorship resistance. If we have an application chain, the chain is decentralized, the application can also be equally as decentralized, and so the exchange itself being something that's obviously of huge risk. If we are going to give this application to users, I'd say if I can't take it down, nothing should take it down. It should be censorship resistance. I think this is like a common trait that most of us, I would say, agree with, right? It limits our liability. So we have an application that we're serving. I do not want to be the sole reason why somebody is going to come after me. And I think we can have multiple parties of trust that offer these sorts of application chain services. And I think that kind of brings a new way of thinking about application chains and their use case. Because you might think as an application chain, if you immediately go decentralized front end, you're going to probably run into some questionable performance, which is totally true. We're going to talk about the enclave sets and why that's true. But I think for app chains, it's kind of a unique opportunity for app chains to bring back this narrative of decentralized front end in this way. So the app chain authority name servers, basically. You have app, you have some multi-sig, and then of course you have chain. So what lives on which? So your application is basically full stack code. You can do full SSR, or you can do CSR. And so however way that you deploy your application, if it's going to just be completely client facing, that's fine. That's actually better for this case. If you're going to be doing dynamic rendering, before you get to the multi-sig, I think it would be interesting that since the domain is already an NFT, we can already set the DNS records of that NFT to a multi-sig before assigning these PEM key files that actually set up your DNS record. And then you can have multi-sig owners that actually rotate the keys or rotate signatures. I guess you can think of it as like basically a DAO. They would have to have, I guess, the same sort of key rotation of these certificates for that domain, say every 90 days or whenever the TLS certificates actually do their rotation. And then of course the chain has an enclave. The application, you could write this in, we found that through doing study on basically doing full React, full TypeScript, full JavaScript, even doing some sort of API fetching with Rust, we found that it was actually compatible with all of these. So that was really great because it started making me think of all the tools that are out there, and after talking to a lot of you guys over the last couple of days, we can also see that if it's a DAO that is controlling this NFT, or if it's some sort of multi-party that's controlling this NFT or this domain, we can also take advantage of these DAO governance tools. And I'm interested to hear more about how that could be serviced. But the chain, yes, it's an SGX, and it's performing some kind of multi-party computation to basically shard your key. And then from doing this, you are then able to do, effectively, you can either do threshold signatures to say, hey, I have these shards that are on these enclaves. Here is the TLS, so that way when your client and the server are making this client-server connection, I can actually be able to sign it, because I don't want to have any one chain or say one validator completely hosting the private key. So at first, we'll likely have to do it in this way just so that we can do proper pre-geo distribution of some kind of sets of certificates. But for now, we can think about what kind of applications we're going to be trying to aim for. So I think the whole decentralized light client thing is very true. Likely we can end up hosting the light client. And then beyond the fact that the light client can be decentralized in this way, we can do verifiable code delivery of some light client that is then saying, hey, you're using some sort of interface and you want to be fetching X, Y, and Z, say data dependencies. We can verify that in the browser. And since you as the client can verify the enclave's hash, the hash of the enclave has a very specific key signature. So that way, if the client is going to be, say, requesting some sort of, hey, can I verify that this is the correct enclave? It'll actually give you a signature back and verify, hey, like this is an Intel enclave. This is basically used by this validator or not, okay? And then, of course, the chain and the multi-sig. You can have either the multi-sig, and I heard some pretty cool ideas with the multi-sig having its own sets of contracts, like through DAOs. But yeah, the chain is effectively able to manage the TLS certificates on-chain or not. So, and of course, the application can have all of its routes stored on other enclaves. So the full implementation that we were sort of experimenting with is sort of like a 4-step process. The first thing that you could do is that you would bundle your application. So most people are using whatever React framework that they're comfortable with. I was testing this with Dino, Remix.js, and basically just creating a bundle file that I was serving to the enclave and requesting that the enclave serve the code correctly. And so I was able to basically use any framework that I wanted, so there was no limitation there. So build however you want. And the way that you would configure the enclave would be very similar to, well, since it's built in Rust and designed to be sort of like a sort of a command line interface experience for you as the server, you would just basically download, click call, install the Cargo DFE crate, and then you would be able to run through the instructions of actually requesting certbot to take this TLS key that's from some certificate authority, bring it in through MPC, and then spread the key across like X, Y, and Z validators. So the first thing you would do, you would assign the domain, the multisig. So I have some domain. A great example is like literally osmosis.box. So we got this one, and we were able to say, hey, like these are our trusted enclaves. Why the enclave? It's confidential and it's also pretty performant. The other things that you're going to be able to do once you have, if you have some validator that's running this particular enclave, it's a general enclave. So you're going to be able to now offer these types of services like joint multi-party computation or any kind of confidential interface that you want to serve to your users. But mainly, I think the best thing is that it's going to retain the integrity of your program and really do verified code delivery. The really cool thing that Flashbots is interacting with, like actually Amazon with, which is like the topic, the news, is that they're doing a lot of like this secure IoT edge computation. And it's really solid to use SGXs for basically a decentralized cloud compute network where you can verify multiple enclaves are to be trusted to run some sort of verifiable back or front end compute for your clients. But where you're not necessarily the one running all the computations, you can actually set up those different enclaves to be pointing in 2 different enclaves to be running these certain operations, which is the nice thing. You can have enclaves actually have smart pointers, and then you can web service these through TLS or TCP. The goal with the validator is that, it's going to be a network of nodes that are basically participating in a multi-party computation for key management and custody. The approach of using an SGX is going to be so that you can MPC TLS the key signature. You're going to use the TEE and sign using the key of the server. And this is how you're going to basically be able to first set up a TLS connection, and then you can do verified code delivery through this TLS connection. So I think that makes sense. these are the things that the validator is then going to be able to do, because we're setting up DFE so that you can actually have the engine so that you can create your own tickets if you need to. You can create your own tickets, you can revoke tickets, you can update the tickets and the DNS settings through HickoryDB. You can set up the code hash for the SGX to code run some FE, so I can say, hey, IPFS, I can proxy the data from IPFS and then do git pull of that git commit hash into the enclave. So you can always verify that when you make updates to your code, you can actually just verify through IPFS, luckily, and then you can say, hey, I have some enclave hash that verifies that this git commit hash is true. So you can serve the code based upon some particular code commit hash is what I was explaining, and then you can use the TLS key that you had set up to kind of run this. Let's Encrypt is the one where you would get these CA services, so can't really get away from this. And you can use GitHub. The only thing is that when you're creating these TLS certificates, you're going to run into a lot of issues that I ran into, of course, that the browser hates you for it. It just doesn't want you to do it. And so the Enclave, you think it would be safe and it would be great, and yeah, Google and everyone else should love it. And that's true if you can get the CA to work for you. I was even trying to use random things and trying to literally pin it through my IP, and it wouldn't even let me. So yeah, this was the problem, and we did get around this problem, thank God. The certificate authority, if you were to get completely around the problem, some people were asking me yesterday, can you just make your own CA? Sure, just comply with all the browser forums, the standards. You would have to secure entire data centers and make your own HSM. You would then have to develop some sort of your own certificate policy, blah, blah, blah. You would have to do audits. You would have to do third-party verification, get in bed with Microsoft and Google and everybody else, just so that you could, again, provide these reports, and then they can deny you from all your services. Why are you going to do this? There's a better way. So we would just do pre-geo distribution of some CA certificate, and I think there's a nice way of going about it. You would have some multi-sig, as I was explaining. You would have everyone sign. You would create your shares, and some public key is shared between all of the validators or just in general servers. You can either do one or two things. I think it's cool to do an initial sign just so you can verify these are my enclaves before I actually do the pre-geo distribution. You would have your shards. You would submit the shards plus some public key. I would say, hey, SGX, basically one of them would say, hey, can you do some Shamir secret sharing? It would say, yes, great. Before I actually run this engine, I'm going to go pull the SSL, the private key, the dirt, the cert, sorry, that says dirt, the full chain, the PEM spec, and I would be able to do this in a confidential environment. You might criticize the fact that it's not private. You're right, it's not, but that's also why we're doing it in a protected enclave, and then we're going to be doing shares, secret shares, where the private key is never going to be exposed. And then we can do this where we can rotate the signatures of this private key. We can, of course, do AES or RSA distribution, something simple. And then if you want to be, I'm a TLS signature between some client and some host, I will do some sort of threshold signature across all of these shards. I'm still looking for better ideas than this. Maybe there's a fancier way of doing it, but the way that you are able to set up basically DNS mapping is so that you can do Anycast, which is basically a way of doing global server load balancing. This is what we're doing, or seeing, sorry, at Suave. We can also use Anycast, which is an entire Rust library that's available to the enclave. So it's interesting that the enclave has turned into its own sort of really nice utility for web services. So the decentralized script delivery, you would say, I'm the user, I'm going to be accessing osmosis.box, do some DNS resolution. The server then resolves the osmosis.box TLD, starts the TLS process by basically returning the IP address. One of the name servers is the correct IP address, but there could be 4, there could be many. That's why when you set the DNS records, you can actually, in Anycast, you can set the DNS to IP mapping, and you would do so by, you can have the engine actually pull the multi-signatures from whoever signed some set agreement. These are my domain hosts and authorities, and these are their DNS to IP mappings, and you can do it that way. When we were experimenting with the Osmosis front-end site, as soon as I started deploying this through the enclave, I was like, oh, yay. And then as soon as I failed, fetching a latest block, I was like, okay, I don't know what you know at decentralized light client land, but I was having a lot of problems when it came to like anything back-end rendering. So I was in the need for basically setting up a way where the enclave is, yeah, it's great for doing the initial code delivery, but the only problem is that as soon as I was doing anything dynamically, I would have to have 2 or multiple enclaves. So I ended up setting up like 4 SGXs just to even start doing this. So there is a better way. We would be able to do dependency verification instead with other enclaves, which I was explaining before. So the client would do some sort of, hey, I want to request, first of all, the SGX proof. I would be able to, as the server, send the SGX proof, where then the client can then verify the SGX proof. I can also send verifiable data directly from the server to the client that they can render either an MP complete or an MP hard problem that they can render themselves. I can also do things like sending ZKPs. I can send ZKPs like a succinct proof or the SP1 proof, which is looking like a really interesting option that a server can start running. They can create their own verifiable code program, and then you can actually compile it into some binary that you can then have a prover-verifier relationship between you and your clients using SP1. I would suggest everyone try it out once. You can do other things like delegating heavy tasks to other DNS enclave servers like Flashbots, and that's actually something that they've been working on a lot with. So we were trying to come up with all the challenges while we were doing this, and we were like, okay, what are the biggest challenges trying to figure this out? First of all, it's the utilization of a DWeb domain. But the way that we would resolve this is that we can, of course, register the ENS handle through .box. We can do a monthly MPC secret rotation on Ethereum or Optimism. It would be awesome if we do .box, .osmosis, right? It would be cool to kind of see us do the same thing that Secret recently did, which was cool. Using the multisig to manage the osmosis.box and then basically map it to the osmosis' front end. For the long-term decentralization and the DNS mapping, basically just use SGX and Suave. We can basically see that Suave is appearing to be pretty promising to implement DAO key management systems for SGX. And that's how they do basically decentralized DNS management. With the verifiable code delivery, again, we can use Suave. If you're not familiar with what Suave is, it's I would call it a decentralized geth that's using, hey, let's shove the EVM inside of an enclave and see if it works. The fact that we can do like major backend processes, the fact that we can do it in Suave using Grameen is pretty promising. Anyway, the verify, I'm going to just skip over this, but basically, yeah, we want to be able to ensure data dependency verification and do the pre-geo distribution that I was explaining before, and then maybe do some DFE governance through DAO would be, I was having good conversations about that too. So the architecture is a lot, but yeah, so you would want to first cache the site, bind, query the bind. You can set the DNS settings inside of the enclave, so this is effectively what your browser is binding to. Once it does this, the browser can then just return the IP back to the browser. You can do other things like initiate the TLS handshake, and thereby your SGX runs. Is able to say, hey, I want to request some code from IPFS or some git commit hash. It can await. It can also do some verify on encrypted disk. So we can verify the hash of that git commit on the encrypted disk. And then tools like Grameen and Fortanix are effectively the same. I'm just going to go and say that Fortanix is probably going to be your easiest bet. We're working with them right now to try to get a little bit further. So that we can start doing full embedded Rust programming inside of the SGX, and they basically were telling us just use SGX Rust, so we'll go for that. I was going to do like a whole thing for you guys today, but like the enclave, anyone can set up an enclave. So just scan this, and this is the entire instruction set so that you can set up your own Rust SGX enclave. You'll start exactly where I'm starting. This will set up your entire server. It's about 30 gigabytes. It has, it does have some bloat, but you can start a new virtual machine on like Azure or Cloudflare or others. And this is the completely standard way. As soon as you run SGX detect, you'll have an enclave running. And our goal is to basically make sure that we deliver to you libraries that are going to be able to effectively serve a front end through the enclave. The reason why I was not able to do this is because currently the embed TLS is currently under maintenance. So thank you so much. Appreciate your time.
All right, there's got to be some questions after all that. Anyone? All right, Jake?
I think this is a problem that affects many teams in this room right now. And so how can we just get, do you have any thoughts on how we can make more of a collaborative effort to make this happen sooner rather than later, especially because we don't know what's coming with upcoming elections and stuff like that, and we need to make sure, like, this is very important to me. So like, how do you see us moving forward and making progress on this?
I think it's a good vibe. I think we all want like more decentralization. We all want more out of the cosmos, and I'm basically trying to make a claim that app chains are perfect for DFE. I think my own personal perspective is that app chains have like a really unique value proposition to do DFE specifically. I think there's lots of companies that could get on board with it. In general, every single app chain is going to want to lower their liability, make sure that their applications are censorship resistant, like all the things that we know and love. So I think maybe the answer is that we just collaborate and talk more about it.
Regarding the microservice graph, is there like room to like consolidate it, like productize it? Excuse me. Regarding the microservice graph, is there like room to like consolidate this or make into a product for like the service providers to?
That's kind of the
make
goal.
It easier?
Yeah, like I think the idea is that like every single one of these steps with like when it comes to doing a DFE, this is confusing, and no one's going to want to go through this entire process. So I think in order to do this, we would want to make a DFE engine or some kind of library that we can just click install once, cargo crate install onto the server. You basically run through the initialization steps to serve the code, to start doing the initial signatures on chain, then to move on to the next step, which is to do the CA certificate pull, to do the initial MPC shard, to then distribute some TLS key amongst X, Y, and Z enclaves that you had previously set, and then you kind of move forward from there. So I think a step-by-step process would be really interesting, but in terms of step-by-step process, this is all described in this. So you'll literally see by just, this is already a container, so IBM and Amazon, they were just like, thanks for doing this actually, because they didn't have a container to run SGX or to just randomly deploy new enclaves that had just like generic enclave, no special, any kind of dependency or library added to it. This is just all libOS, C, and Rust. So this is how you can start making your own sort of embedded programming. And I would say for this, the way that it would be really cool is basically to have like a set of binaries that were attached to the DFE library. That way, all the processes and the steps to launch, deploy a front-end application that is in this style or to decentralize it in this way, yeah, you could basically run through these processes one by one and create a binary for each of these operations. For example, just the request code to get commit hash to the enclave was just one specific binary that you would just run on the server, and it just does it on its own. You would just want to initialize which get CID was you were basically pointing to.
All right, thank you, Dylan.
Thank you.